Let's get things started. We've got Justin Clacherty doing building automation. How secure is your home or workplace? I'll let him do a little bit of an introduction on himself, and we'll get things rolling. Once again, just a reminder to turn mobile phones after lunch onto silent, and if anyone wants to take any calls, do please pop out of the room. If you could give him a round of applause just to get things started, guys.
Hi, so I'm here to talk about building automation. I know this is a technical stream, but I won't be overly technical in some of these things. It's really the overview of the systems and what people are using and what some of the issues are. Maybe if people show enough interest, then we'll look at doing something a bit more hands-on next year. So about me, I'm Justin Clacherty. I'm Managing Director of Redfish Group. So we're a small product design company, do turnkey electronic product design, a lot of telemetry equipment for different companies. So we do things from electronic hardware, the embedded software on that hardware, communications, back to base, putting data into databases and sometimes web apps to actually display the information. We also develop some of our own products, and at the moment we're working on some stuff for the building management systems, which is where this talk comes from. We've worked in lots of different industries, so mining, telecoms, marine, power industry, consumer and industrial electronics, you name it, we've kind of been in there. You can also see me on Twitter. It's OAA SVC. You'll find me ranting about security, privacy, and politicians, usually. Okay, so building automation, what is it? There's two styles of it. You've got commercial building automation, which is the majority of what I'm speaking about here. So that's going into hotels, apartment buildings, big commercial blocks like an Energex building or TAB or something like that. And then your next lot is going to be residential, where people are wanting to put something in to automate their home. They'll also, generally, if it's an automation system for residential, they'll want to add in things to do with AV so that they can control their televisions and sound systems and whatnot. Whereas that's not so much the reason for doing that commercially. It's primarily used for energy, reducing energy consumption. So people are using it, especially in your commercial situations where you have huge energy bills. They use it to make sure that lights go off when people leave meeting rooms, and lights automatically go off when people leave a level. It controls things like blinds and air conditioning so that as it gets hotter, it'll start to close off sunlight from getting in just to get a little bit more, it'd make it a little bit cooler without using energy, things like that. And because that's the primary reason for it, especially for commercial buildings, where you have multiple people wanting to manage different buildings, they'll also have all this data going back either to a cloud service or back to some center where they're managing all this. So a command center. So within building automation, there are an awful lot of different protocols that are used. It's quite disparate. We've got Modbus, there's BACnet. BACnet's used a lot in the US. Modbus is primarily used in industrial systems, but it's also used in dealing with energy meters, water meters, essentially the industrial systems in a commercial building. KNX is a standard. It's the only one that actually has a standard associated with it. It's an ISO standard. That's primarily used in Europe and the Middle East, I believe. We're gaining traction in Australia, so there's a lot of new installations happening in Australia and also in India, and it's entering into the US and South America. You've got C-Bus, which is very big in Australia. It was designed here, I think, by Dynalite. It's difficult to get out of Australia. It's not too bad. Some people have problems with it, but because it's only really used in Australia, there aren't really a lot of options for putting in different sensors and things. Lawnworks and DALI, which is just for lighting. It's a lighting control system. Now, who designs these things? There's a few large manufacturers. I'm talking mainly about KNX here. It's what I deal with and what I understand. I've also dealt with a lot of the other things in there, but this is what I'll focus on. There's a couple of major, like tier 1 players in building automation, and this is across most of the different buses that are available anyway. You've got Siemens, you've got ABB, but then a lot of the rest are just from really small niche companies. With KNX, a lot of them are in Europe, mainly Germany, some in Italy. And being small companies, that can be an issue, and that's something we'll talk about in a moment. The people who install it are essentially electricians. So electricians get certified for particular building management systems that they use. They go around, lay down the wires, install the sensors. If the system uses servers, they install those, and then they configure it. So they have an understanding of electrical systems, I guess, but not so much when it comes to information technology or security. There's also integrators who are part of designing the overall building management system. So you've got to decide what sensors you want to put in, whether you're using something like KNX or Modbus. If you're putting intercoms in, what intercoms you're putting in, what do they speak, how do they integrate together. So those are generally done by people called integrators. Quite often they're also electricians who have just been installing things for a while. So while they're supposed to be overlooking everything, overseeing everything and making sure things work, they may not have the expertise that's actually necessary to do it when it comes to security. Now, a lot of the things as well are embedded systems, and I think we all know what problems there are in embedded devices these days. So now we come to the Internet of Things. So Internet of Things is obviously the new buzzword that everyone's on about, and homeowners and building owners go, oh, well, I can get my fridge on my phone, so why can't I do something with my building? Why can't I check what the temperatures are? Why can't I go and turn lights on and off remotely? Why can't I see my security cameras, my intercom system? So people are trying to push building management systems into that era or that niche, but it happens slowly, but it is happening. That's probably not a good thing, which most of you would most likely agree with. Yeah, as it's got up there, the nuance of what it actually means to put systems on the internet escape the installers and integrators that are using these things, and even to some extent some of the developers. They're coming from the embedded world. They're used to sitting on their own little networks and not open up to the rest of the world. And they don't even think about it. They just go, oh, well, we've got IP, let's put it on the internet. So, issues. And we will get to something technical soon. Embedded development and security. So, that's a big issue. We'll go further into that in a sec. Protocols and standards. So, as I said before, there's a whole heap of disparate protocols. Nothing standardized. We've got the KNX standard, but that's only in Europe, and while it's being pushed around the world, it's still not everywhere. And just because it's a standard doesn't necessarily mean that it's going to be fantastic. It just means that at least we've got something we can work to. And also when it comes to integrators, installers, their expertise and how they work with making systems interoperable, making sure that the systems don't talk to each other when they shouldn't. and making sure that they're secure if they're going to be on a wider network. So embedded development. Are there any developers here? Oh, great. Embedded developers? 1, 2. Excellent. Well, it's great that you're actually here. What tends to happen in embedded development is that they're terrible at security. And this is in my experience anyway. Essentially, you're making all these small little devices. You're running, depending on the system, you might be running on a bare system with no operating system. It may just be taking some sensor data, shoving it over Bluetooth. But then people come out and they go, okay, well, we want Ethernet devices attached to this, so they add in an Ethernet device, grab a stack, which may or may not have been audited, and put that on there. It's most likely riddled with buffer overflows, but trying to get through to, first of all, you need to make that leap and actually get embedded developers to care, and they're not lazy, they will care, but then they have to convince their bosses, and their bosses have to convince their clients, and it can be a difficult task. So they have little experience in security. It would be great if they got more. I certainly try to get my guys to learn what they can about security, and we're doing our best to make sure our customers know about it. So developers, please let everyone you know about this stuff and get it working. But essentially, there's no incentives from clients or business owners or even government to make sure these things are going to work, and I'm not sure what we do to make that better. One of the other problems is that in some cases they're running outdated systems. So what happens in embedded development, you choose a processor, you make some electronics, and then you will choose to either make your own software on there, or it might be something that warrants an embedded Linux system on it. Now, what tends to happen in a lot of the smaller companies is they'll go, okay, well, say I've picked a Freescale semiconductor, a Freescale CPU. Okay, well, Freescale offer a Linux distribution for this. Great, we'll grab that, put it on there, and then they put their application on, sell it. That's great. It has a 2.4 kernel on it and hasn't been updated since 1990 or something. So 1990 is a bit early, obviously, for Linux, but that's something that really needs to stop. It's getting better. A lot of the semiconductor manufacturers are starting to move to newer distributions like Yocto, which are actually maintained quite well, and you'll get security patches through to them. But the people who are actually manufacturing it aren't going through and actually checking to make sure everything's working and making sure patches are coming in. The other problem is there's a lack of updates. So even if patches come in, there's no guarantee that that will actually get out to a device in the field. So within the building management systems, there's lots of protocols and standards. It's just a mishmash of disparate protocols. There's no real clear winner. It really seems to be a regional system. So, as I said, BACnet in the US. Here we've got CBus. Europe, they've got KNX, and there's a few others floating around in there. The only standardized one is KNX, but even those standardized ones are quite slow to adapt to things. So KNX the standard was written many years ago. It's updated constantly, but there's quite small progressive updates. So when they came along and they want to put IP on it, then that's just a slight change to their twisted pair system that they have. Security is just not in any of the designs of any of these things. A few of them are starting to put some things in there, but it's a bit piecemeal. We'll just see how we go with it, I think. So KNX, this is the one we'll look at the moment. They say the KNX is the worldwide standard for building control. It's an ISO standard, let's see which one there, and used in the EU and Middle East. As I said, we're growing in Australia and it's growing within India. And I think our company's the only one that manufactures within Australia, but I'm sure other people will pick that up. There's something like 400 manufacturers, so you have a lot of different devices being made out there. It's probably got the largest number of manufacturers for a particular protocol. Now, what it essentially is a field bus. So similar to Modbus, essentially. You have, originally, it was a twisted pair, so a serial protocol that was multi-dropped over a serial, or over something similar to an RS485 system. The system has no server in it. It's essentially configured at install time, and it stays that way forever, unless someone comes in and reconfigures it. Now, it's a nice idea that it's distributed. That means that if one thing breaks down, the whole building management system doesn't stop. It makes it a little difficult if you want to put anything smart in it and do make some smart control where you actually adapt to things that are happening. It's really up to the installer and how good your installer is to know, okay, well, I want to turn the lights off when this happens, or when the temperature goes, I want to do this. It works by a subscriber, a publisher-subscriber sort of system. So there's effectively these group addresses. So you've got a light that has an address which anything can grab and turn it on or off. Then that light might be told to listen to a particular address, and that address might be something that any number of sensors write to. And when they write to that, the light will do something based on that, so it'll turn on or off. The blinds will come down or go up. And so it's quite simplistic, which is fine for what it is. But it makes it really easy to reverse engineer if you actually manage to get into one of these systems to exploit. So the problems that are in there, and I'm only going to assume that this is a problem with every other protocol as well, because the ones I have looked at have these same problems. So in KNX, your data packets are called telegrams. They're effectively the equivalent of like a UDP datagram that you would send over Ethernet. There's no authentication, so you don't know who's sent a message. Nothing's encrypted, so you can always read it. So basically, if you get on the bus, you know everything that's happening in the system. The IP implementation is effectively that twisted pair implementation and just encapsulated in a UDP datagram. So without any security or authentication, it makes it simplistic to get in there and do what you want if you manage to get in there. A lot of people think this isn't an issue. Oh, what's it matter? I can turn the lights on and off. Who cares? But the problem that happens is that once you get into bigger building management systems, we start to put things like door control systems on there, so access control systems, and they'll be on the same network. They might talk, in some instances, they may actually talk the same protocols, so it might be something as simple as KNX that they're talking. You have monitoring systems and intercoms, same deal. You'll be able to get in there and you'll be able to get into these intercoms, open doors, listen to voice data once you're in the network, and see video data. So with all that in mind, no authentication and no encryption and simple small UDP packets, everyone says bring on the IoT, it'll be great. So installers they don't understand networks, so they just go, oh, well, we'll open it up onto the internet. So grab the firewall, port forward to a KNX net IP interface, or a Modbus one if they happen to have it, and that's the end of it. Oh, you can get in and you can run your application and on your mobile phone, and you can turn your lights on and off. That's really good, isn't it? Others, they might come in later on and they want to reconfigure things. So they go, oh yeah, well, I'll put the system on to the internet so that I can just connect to it from work, and that way I can reconfigure the whole system for these people. Some are kind enough to use VPNs, not all of them. So you can see some problems here. Now, how many of those systems do you reckon are open on the internet? Lots? Well, the top two are the latest Shodan figures. It may actually be larger than that, I don't know, but that's what Shodan tells me. So there's 11,400 odd BACnet systems on there. Modbus has 11,599. Now, there'd be more than that. Modbus has an IP side of things, and then there's Modbus, which is a twisted pair RS485 system. So this will just be Modbus IP. It won't take into account where people have some sort of gateway onto the system. KNX, now that's a number from 2014, 3,295. I really don't think that's correct. I've heard numbers of 13,000. My system that's doing a scan at the moment is still running it, so I don't have the real numbers right now. But even if it's only 3,000, that's pretty much Germany and France. So that doesn't take into account any of the rest of the systems, or any of the rest of the countries that have been building up KNX systems. So, is everything horrible and going to die? Probably. KNX has got an organisation that manages the standard, essentially. They recognise that there's issues with this, so they're currently working on Cannock Secure. It's not ratified yet. I've had a look at it. I'm not convinced it's wonderful, but it's a step in the right direction. So they're looking at adding in authentication. They do encryption on the actual data payload, but there's no encryption on anything else. So you could get in there and rabbit around and change things. And given the size of the actual packets, and that you pretty much know what they're going to be, it's probably not going to be that difficult to reverse engineer whatever they've done. But we'll find out in the future, I guess. The other problem is that manufacturers are typically really slow to, excuse me, manufacturers are really slow to adopt these things. So if the secure system gets ratified this year, say, you won't really see things trickling out for a while, I wouldn't think. Now the next thing is web services. So are any app developers in here? Excellent. So I presume everyone knows an app developer and also knows that they really don't understand protocols. So what an app developer wants to see is a REST interface. They understand it, they can work with it. There's no REST interfaces that are standardized for any of the building management systems. So basically, each company makes their own, and those companies tend to be the faster moving companies, so these smaller companies that are making embedded systems. The difficulty with that is they just don't have the capital or experience to make APIs that are actually going to be strong. Many of them won't even bother with SSL. Some will, whether they have a new enough version of OpenSSL on their system that it matters, I don't know. I know of several that are running, as I said, the 2.4 or 2.6 kernels, so I doubt they're running a new SSL. KNX is trying to do a web services API. It's not finished. I'm not sure that they're going to be able to get something out soon. So once again, disparate technologies, disparate protocols, and designed by people who aren't likely to be doing the things that you need to do to make these things secure. And they'll just be put straight onto the internet. Your other problem is the integrators and installers. So they have, how am I going for time? Okay. So they have very little networking experience. They have no understanding of security. they're just electricians, not just electricians, but they're electricians who have specialised in building management systems. They're familiar with the different devices that are there, and they can put them in a system and make them work. The building industry is really low tech. So they're going to go in there and install something, but typically there won't be anyone overseeing any of this. So where you've got multiple protocols or multiple devices that all speak on a network, there's no one actually there. In general, there's no one there actually designing a system. So you'll end up with security systems on the same network as your meters, which are on the same network as these KNX devices, which are easy enough to break into. Your DVR will be on that network, and in some cases, it'll be going back to a data center for a larger company, and that'll just be sitting on the same network. So you can pivot straight into the company's data centers, which is really not good. Unfortunately, they don't seem to realize that. So yeah, as I said, there's a lot of different systems that are being put together. So once you start looking at multiple protocols and multiple systems, you really need a professional systems engineer or someone sitting over the top and actually deciding, will this even work with that? If it does, where should it sit within our network? Should it be available to the internet? Should it be on a completely air-gapped system? And that just doesn't happen. I can't speak for Europe. It may happen in Europe. There are some larger integration companies which seem to do the right things, but there's also a lot of smaller ones. Now, these are going into banks, these are going into hotels, residential apartment blocks, and then houses as well. So mistakes tend to be made. It's just a nice list of some of the things that actually go in there. So we've got DVRs, door control. The door control is probably the biggest worry, I think. Lift control, so you could stop lifts if you wanted to. HVAC, so that's heating, ventilation. Once you get in and start to control that, you can do all sorts of nasty little things. Power generation, so there'll be generators sitting on these networks sometimes, so that once power goes out, it automatically kicks over, but you could get in there and just start it up yourself. Intercoms and metering, so that's water or energy metering. So who cares about all this? No one. And that's the problem. As I said, you've got low-tech people installing it. They don't understand the risks. You've got businesses who don't even know that there are risks. It's trivial to gain access to a lot of these systems. So if you had a look at one of those 3,000 KNX systems on there, you can connect to it and listen to all the traffic on the KNX network immediately. There's open source libraries which support KNX. Same with Modbus. There's open source libraries to talk Modbus. You'd just be able to listen in on the lot and see what's happening. Once you're in, you have complete control of the building. From there, you can pivot to whatever. So if they've got it on the same network as their servers, you get in there, you can exfiltrate data from servers. So if it's a hotel, you've got the customer's details. If it's a hospital, well, there's all sorts of nasty things you could do there. Is there some light at the end of the tunnel? I'm cynical, so I say no. But I'd like to think that I'm wrong. I'm working on a system at the moment with someone, and one of the things that ended up coming out of that is they had a system design and they decided to use iPads in the buildings, thinking that they could just set that up straight onto a network. 3/4 of the way through the building design, oh, we can't do that, so they want to put Wi-Fi on it. So you've got Wi-Fi sitting on a building management system for a large residential apartment block used by people who really shouldn't be getting access to. I believe you can actually see the Wi-Fi from the street nearby, so you've got access to everything there. And on there you have as I said, once I got in, I changed it so that the access control systems are on a completely separate network at least. So ideally, the worst case scenario is that you can turn lights on and off, but there's still a DVR system sitting on there, so they can watch who's coming and going and then decide when to go in. Yeah, it's not really good. Hopefully someone will learn soon. Cannock Secure is obviously a step in the right direction. Now, if Cannock is doing it, I presume some of the other larger organisations like BACnet are doing the same thing. CBus maybe, I'm not sure. I know they open sourced their library, their protocol recently, so it's possible they're looking at security. But really what we need to do is find some way to educate the smaller manufacturers and the developers and make sure that they're actually doing the right thing. I'm not sure how we do that. I'm open to suggestions on it. So that's it for me. So if anyone has questions.
Yeah, we do have a couple of questions. First one from, let me just bring it up on screen. Do we have the questions up? I'll just read it out. So the first one is, how many of these devices are wireless? What does the RF attack surface look like in typical building installations?
Okay, there's quite a lot of wireless stuff actually. So within KNX, there's 3 physical layers at the moment, I believe. So the initial one was twisted pair. There's a KNX RF. I believe that sits on 900 meg, I'm not sure. I don't think it would be higher than that because the walls in Europe are too thick. So 2.4 gig doesn't penetrate very well. Now the RF ones, they're going to be using essentially the same datagram packets. There is Ethernet obviously, and with Ethernet comes Wi-Fi. Then you've got your Zigbee systems, Z-Wave, which I think is Zigbee based. Enocean is another company that has their own protocol. It's quite nice. The switch effectively generates enough power, so they're not powered devices. The switch generates enough power to send out the commands to talk to things. But that's switches in every building. So yeah, there's a lot of wireless out there, and that makes for a fairly large attack surface. Plus, as I said, the people who are installing this don't really keep security in mind. So once they go and put something like Wi-Fi there, it's anyone's guess at how well that's put together. I mean, a lot of IT companies don't really do Wi-Fi well, so I don't imagine builders are going to.
Well, that kind of ties into our next question, and that is, do you see commercial automation as a typical IT issue or the building owner's issue that should be managed by specialist vendors?
I think it's a bit of both, really. IT needs to get involved, and they need to be aware that these things are on a network, and they need to be aware that those things need to be on a different network, at least to their servers, data centers, and basically their operational network. This is a problem already. I've worked in gaming, so poker machines and things like that. And there's clubs out there, quite large clubs, where all the poker machines are sitting on the same network as the office computers. That includes the computer sitting at the desk at the front, the reception desk, and obviously any point that you come to. So that's just ridiculous. And those things are then talking off to Treasury as they need to in Queensland. I'm not sure how it works in New South Wales or other countries. So it's a mixture. You still need your specialist vendors though, because there's no way your IT company is going to be able to deal with all the different things that come out of building management systems, and they really shouldn't need to. But they do at least need to know that it exists.
And that actually kind of gives us our next question, which is, can you give some examples of major incidents that have caused some embarrassment?
I can't actually. There was obviously a recent thing. I think someone from, it was on to AusCERT2016, I believe, recently. Someone got into a hotel management, building management system through Wi-Fi. I don't know of any major incidents that anyone knows of at the moment. Sorry? Did they get in through the air conditioning system? Oh, yeah, okay. And that's the thing. If you can get into any system, you can come in and get into others. But yeah, I'm not aware. But Target, great. That's highlights exactly what the problems are.
Okay, I think that's it. We'll finish up. Just on behalf of AusCERT, thank you very much.
No worries.
So this is a little gift. It's a handmade bowl of macadamia nuts, which is kind of a little piece of Queensland for you to take with you. But thank you very much.
Thank you.